Welcome to our June 2014 Hangout. Today I'm going to be talking about firewalls and virtualization. First, a bit of project news. We have training registration now open for our first two in-person training sessions. August 1st, 2nd is the first one, and the 2nd, 5th, and the 6th of September. These are in person here in Austin, Texas. And you can get more info at pfSense.org/university. There will be more other ones to come, and potentially in other locations in person, maybe online at some point. If you happen to have a significant enough group that you want us to come to you, that's certainly a possibility as well. If you have enough people to justify it, so get in touch if it's something you're interested in. And 2.1.4 release just came out yesterday. The day before. I'm losing track of days. All the release notes are out on the blog. It's a security update release and also some bug fixes in there. So just a brief overview of virtualization. We don't really have time to get into great depth, but to just kind of set up expectations of what we're talking about. So a hypervisor is just a means of running multiple operating systems on a single piece of hardware. There's a variety of types. Originally, they were kind of classified as type 1 or type 2, at least as we're talking about x86 architecture, not going back to like the old mainframe style virtualization, where type 1 and 2 differentiates between a hosted hypervisor that runs on top of another operating system and one that's bare metal that does not actually have an operating system that it runs on. Some more recent hypervisors are kind of blurring the lines there. There's KVM on Linux and Beehive on FreeBSD that are kind of 1, kind of 2, depending on how you want to look at it. And so there's been some arguments of whether type 0 should be created or 1.5 or so we won't really use the specific type, and we're not going to be pedantic about any of the classifications along those lines. I've basically split up hypervisors into just 2 different classes: desktop class systems and server class ones. Where the desktop class ones are largely only suitable for testing and development kind of uses, and server class is more if you want to actually put a virtual firewall in production. That's the appropriate type of hypervisor to use. So there's 3 usage scenarios that we're going to be talking about: production systems, testing and development environments, and then some fun but ugly hacks if you find yourself in a pinch and you need to do something a little crazy. You can do some fun things with virtualization and firewalls, but not necessarily something you want to run in production long term, but something that'll get you by if you're in a pinch. So one of the things that always comes up is people ask, is it secure? A lot of people will claim that it's not so much, because you're sharing that physical machine with other machines, so there's got to be some ability for something to get from one VM to another or something like that, or that can't possibly be secure. Time has proven that it actually is pretty secure, and there have been vulnerabilities in hypervisors over the years, but not a huge number of them considering, and not very many severe ones. The class of vulnerabilities that you're usually concerned about in those kinds of scenarios are guest to host or guest to guest, where a virtual machine can potentially exploit the host system that it's running under, would be guest to host, and then if you compromise the host from the guest, then all the other guests are essentially a lost cause at that point. It would be equivalent to having physical access to all of them. So that's a pretty significant issue, if there are any. There really haven't been that many, though. Guest to guest is where one guest can compromise another guest due to vulnerabilities in the hypervisor. Also not extremely common, and neither of these scenarios are something that have had a lot of script kiddie ready type of exploits put out there, and they really haven't been widely exploited in any case. That's always something that's subject to change, and some people have claimed for upwards of a decade now that this isn't something you can trust to be secure. Well, we've been through a decade of this now, and we've not really had that many instances of any kind of serious security problems. So by and large, you can say that this is reasonably secure. Keep up to date on your patches. Stay up on all the latest trends in virtualization security, because it could change at any time. But if a huge range of issues haven't been found by now, they just probably aren't there. That may prove not to be true, but at least to date, things have been pretty solid. But it's just like any other piece of software. You have to keep it patched and up to date. Probably the biggest security risk that I see in virtualization environments is that it's more subject to human error. Especially if you're mixing significantly different trust levels of networking on your virtualization infrastructure. So if you virtualize your firewall and you have your unfiltered internet plugged into one NIC of it, and your internal network plugged into another NIC of it, it's not all that difficult to accidentally click the wrong button and drop one of your virtual machines on the outside part of the network. In which case, depending on what type of internet connection you have, that machine may pull a public IP and may be completely exposed to the entire internet with no firewall or any other type of protection. That's much easier to click the wrong button than it is to actually go back in your server room and plug into a completely different switch. Generally, one that's probably not even close to the one for your internal network. So just have to be a little more careful about what you do. That's probably your biggest security risk. But make sure you stay up on updates and patches, and just be careful what you're doing. And you'll be in good shape. And before we get into the specific usage cases, I'm going to go through the different types of networking that you have on hypervisors. So you have a good understanding of what options are available and how those work. So in the desktop class hypervisors, you have four types of networking. Generally, you have bridged, NAT, host only, and then internal. And we'll go over each one of those in more depth here. So a bridge network will put the virtual machines connected to that internal vSwitch on the same broadcast domain as a physical NIC. So it will essentially look like this, where you have your physical NIC in the machine connected out to your physical network, where you have a physical firewall in this example. And then that has a bridged virtual switch there. And then your virtual machine connects into that bridged virtual switch. So from the perspective of the rest of the network, this VM that's sitting inside of this machine here looks like it's actually just plugged into another port of this physical network, more or less. It's all on the same broadcast domain there. But there are some things to watch out for whenever you're doing bridging with virtualization, or just in general. There are some caveats with wireless, just by the nature of how 802.11 works. A wireless card that's connecting to an access point, it can only pass one source MAC address out of its NIC. So what the desktop class hypervisors will do in that case, they actually will translate the source MAC of the virtual machine to the host's wireless adapter's MAC address. And that, generally speaking, works okay. Depending on your hypervisor, it can potentially have some limitations. Usually works fine with IPv4 at least. They're like VirtualBox, it doesn't work with v6 or any protocol other than IPv4. There might be other restrictions in that scenario with other hypervisors as well. Also poses complications if you're trying to get to the VMs from the physical network. So you'll see the MAC address then of the VM rather than as its real MAC as it exists inside of the on the bridged virtual switch. You'll see it as the wireless card MAC of the machine that the hypervisor is running on. And some of them do an okay job of properly passing that traffic back in if you're trying to connect from the wireless network back into the VMs. But a lot of times that's hit and miss at best. So that can be an issue if you're using a wireless NIC. Depending on what you're doing, you may be better off using NAT or one of the other options rather than bridging or use Ethernet. Also need to be careful whenever you're using bridge VMs because that's the option that has the most damage potential to the rest of your network at least. The other networking options, virtual network options, your impact is largely going to be exclusive to the virtual networks. It won't leave whatever machine that the hypervisor is running on. But if you do something like set up the LAN NIC on a default pfSense install on a bridged vSwitch that goes to your internal LAN, then you've just brought a rogue DHCP server up on your LAN that's going to start serving out IPs to things in your LAN. IP conflicts are a potential issue as well. If your gateway IP is 192.168.1.1, for one, you should probably change it to something more obscure. But two, then if you bring up a VM with the LAN connected to a bridge with the default IP on it, then you're going to have an IP conflict on your gateway IP, and that will cause some grief for the rest of your network as well. If you're doing any kind of work with CARP in the virtual machine, you could potentially create CARP VHID conflicts. The VHID of CARP IPs determines what the virtual MAC address is that's in use on the system. So if you set up CARP on the bridged environment there and use the same VHID that's already in use on your physical network, you just created a MAC conflict, and that's just as damaging as an IP conflict. It would cause all kinds of connectivity problems. And the last issue is layer 2 loops. We hear of people creating on occasion. If you have a virtual machine pfSense and you have two NICs on there, you stick them both on your bridge virtual switch, and then for some reason you decide to bridge those two NICs together, you just create a layer 2 loop that will probably melt down your entire network if it doesn't just take down the hypervisor first. That's not to say bridging is a bad thing to do. In a lot of cases, it's the preferred thing to do. But if you're using a desktop system and just kind of messing around or testing things or things like that, in those cases, I tend to not do bridged. And then the next type of virtual networking is NAT, and that's where the hypervisor enables you to share the host's IP or IPs. Sometimes it includes VPNs. It depends on what kind of VPN client that it is. And that's handy because it's just easier to deal with depending on exactly what you're doing with the VM. If you can automatically get it to go out of any VPNs you're connected to and go out to the internet without having to worry about, does it have its own IP, or am I on wireless and the deal with the MAC translation is going to cause me some kind of grief or something along those lines. That makes things a little easier to deal with in those circumstances. And the fact that it's on a separate broadcast domain is safer because all of those things that we just discussed on the last slide are not possible, or extremely unlikely at least, whenever the vSwitch is on a separate broadcast domain. So it gets out in that case via a NAT router that is inside of the hypervisor, which probably be more clear on the diagram coming up here. The downside to the NAT is there will be complications reaching the VM from the physical network if you want to initiate traffic from the physical network back into the virtual machine. That's either going to be not possible or require some additional configuration. Some of the hypervisors have like a port forward feature where you can forward certain things off of the host's IP into the VM that's on the NAT network. But generally speaking, if you need a host on the physical network to be able to initiate traffic into a virtual machine, you're going to want a bridged virtual switch in that case, or to route through a firewall potentially, rather than just the built-in NAT in the hypervisor. So this diagram here illustrates how the built-in NAT in the desktop hypervisors works. So you have a virtual NIC on the host. Whether or not that actually shows up on the host depends on the hypervisor. VirtualBox doesn't actually show it as an interface on the OS. VMware does. Varies a bit from one to the other, still works the same. So you have a VM here, the NAT virtual switch. So the NAT subnet that was assigned is 192.168.56. Dot one generally gets automatically assigned to the virtual NIC that's on the host. The subnet may be statically assigned, or in the case of VMware, it generally looks and sees what subnets that you actually haven't used, and it'll pick something random in the 192.168 space that it doesn't find that you have in use. So then everything gets the 192.168.56 IP. There is a DHCP server enabled within the hypervisor to serve out IPs on the virtual switch. And then the gateway becomes the 56.1 that is that is within the hypervisor. So traffic that goes to the 56.1 that's destined out to somewhere else ends up hitting this NAT router that's within the hypervisor. It's not actually really something you can configure much, if at all. And then it translates your source IP to the IP of the physical NIC. So this machine over here that's got a 192.168.56.10 IP, whenever it gets out to the physical network, it will actually show up as 10.0.0.10, the physical NIC's IP on the host. And another type of virtual networking is host only. So that allows connectivity to the host, but there is no routing or nothing outside of that that's provided by the hypervisor, at least. So the host only, there's a virtual NIC on the host OS, and it has an IP assigned to it. And then you have the host only virtual switch. And usually the hypervisors will enable a DHCP server by default on there to serve you your VM's IPs in that subnet. And then you'll be able to communicate from your host to all of your guests on that network, but no routing, unless you bring up a VM that actually does the routing for you. And then the last type is internal. So that type has no connectivity at all to the host on that vSwitch at least. So where the other types, they have a virtual NIC on the host that connects into the virtual switch. In this case, that's not the case. This virtual switch is just something that resides within the host, and then you can connect your VMs to it, and then they can communicate between each other. And then, as long as you don't have any kind of router or firewall or anything on that virtual switch, you'll know that they'll be contained within that network, and they won't be able to get out of it. Okay, I'm going to pull up a machine running VirtualBox here. Okay. So there's a couple of different places in VirtualBox where you can configure the virtual network. So if you go to File and Preferences, and you go down to Network here, it will then list the NAT networks and the host-only networks that are available. The NAT networks that are listed here are actually separate from the NAT network that we discussed in general. This allows you to find additional NAT networks behind the default one that's built in. That's a little bit different than some of the other ones in that they differentiate between these custom created ones and just the stock built-in one. And then the host-only networks are in VirtualBox, they're ones that actually do show up as a NIC on the system. So this is the adapter for the network that we have here. And you can edit it and set what its IP is, and enable DHCP if you want, and give it a range. And if you get into more complex kind of networks, it can be helpful to have multiple host-only virtual networks if you want your host to be able to directly communicate with those. And then there's a second place to configure internal-only virtual networking. So if you go to the settings on any virtual machine, and then you go to network, you'll see that you have the option of what to attach it to. So you have the bridge adapter, the NAT, which is just the default built-in NAT. The NAT network is the additional NAT networks that you can define that we were just looking at. Then there's bridged adapter, and then that lists all of the interfaces that exist on your system. You can tell it specifically which adapter you want to bridge to. And host only, same way with that. We only have one host only network, but if you created another one over there, it would show multiple in the drop down there. And then the internal network, and then you can define here whatever you want the name of the network to be. And once you create one on any virtual machine, anytime you go into the rest of the virtual machines, you will get a list that includes the names of those internal networks that you've created on the other VMs. So it's easier to connect it up to the internal networks that you've created elsewhere. And it's the same essentially for every other adapter. So you can configure up to 4 adapters here in the GUI at least. If you manually hack the config, I think you can do 10 or 12 or something like that. You can do a few more. The settings under advanced, the adapter type is what type of driver that the hypervisor presents to the guest. So Intel Pro 1000 is generally a good choice regardless of hypervisor with anything to do with pfSense or anything or any other OS for that matter. Promiscuous mode is whether or not you're allowing the machines to put their NICs into promiscuous mode so they can pick up things other than traffic destined to their own MAC addresses. And the cable connected checkbox is whether or not the NIC actually is being shown within the VM as having its link plugged in. So it's checked by default, but if you needed to simulate, what happens if it was essentially the same as you unplugging the Ethernet cable out of a NIC, you can uncheck that, and it'll make the VM see that its NIC was unplugged. And then we'll look through the same things with VMware Workstation. It has a good deal more capabilities than what any of the other desktop class products have. you went to Edit and Virtual Network Editor. So here's part of the configuration where you can define which VM nets are of which type and what NIC they bridge to if they're a bridged adapter. So the VMnet 0 is the default bridged adapter, and the connection that it chooses is auto bridging, which means it will pick whatever it thinks is the best NIC to use. So, for instance, if you're on a laptop where you have a wired and a wireless card, it will automatically figure out whether you're plugged in or on wireless at the time, and that works really well. That if you have that kind of a scenario where you're using it on a laptop for test or development kind of purposes, and just leaving it to the automatic is probably your best bet. If you're doing something a little more involved, and you probably want to bridge it to a specific NIC in that case, so you can pick the physical NICs in the system, and then if you have certain other types of adapters here, you can pick those as well. So actually, you can hook VirtualBox to VMware via its host-only Ethernet adapter by choosing that. Not sure there's a really great reason to do that exactly. I have done similar to that with GNS3, which is a Cisco emulator of sorts, to do some interoperability testing. It's works really well actually for any kind of testing purposes. And then the VMnet 1 is the default host-only network. And then it does have a virtual NIC that does show up in Windows. So that's that NIC there. And it lets you configure what the DHCP options are, what the lease length is, what your scope is that it hands out via DHCP. And then VMnet 8 is the default NAT adapter. And the NAT settings do have some port forwarding, so if you need to let some kind of traffic back in from the other side, you can. You also have the ability to add any number of additional VM nets. So if we just want to add a VMnet 2, and then maybe we bridge this one to our first Ethernet card, and this one to our second Ethernet card. So if you have multiple Ethernet cards in the system and you want certain VMs to go to each one, that would be the way to do it. And then whenever you go into your VM settings and you choose the network adapter, here you'll have the options of what type of adapter to make it. If you choose bridge, it's the default very first bridged item that's in the list there. So the second one that we created that's bridged, that's a VMnet 2, if you wanted to use that one, you would have to actually choose custom and then go down here and pick the VMnet 2. And there's also LAN segments in Workstation, and they are configurable from here. And these are global across all the virtual machines. So we might want to create test LAN 1 and test LAN 2. And that's an internal only network vSwitch at that point. So only the virtual machines could talk to each other on that type of segment. The advanced options on network adapters can be useful if you're want to do some kind of simulation of sorts. So if you had pfSense here and you wanted to put a speed restriction on its WAN and see how things would behave with a T1 speed on it, and even adding a bit of packet loss to it to see how things behave in that case. That can come in handy. And we'll get into some more specifics on how to actually set up some of those examples in a bit. Now, the other two major desktop hypervisors are Parallels and VMware Fusion, both for Mac, and they have the same basic capabilities of VirtualBox and VMware Workstation. They have the bridged, and they also have NAT, which they call shared in that case, and then the host only as well. They don't have quite the bells and whistles that some of the additional options that you can set up, especially in VMware Workstation, but not quite as much flexibility as what VirtualBox has either. They do at least have those three basic options. One thing to keep in mind as you're setting up things along these lines is how you have your host OS configured. One of the security risks that I didn't mention previously with desktop class kind of hypervisors is what if you're putting a NIC out to your internet connection and the host actually binds an IP to that, then it's going to be exposed outside of the firewall. So we have the primary NIC here, there's the LAN NIC, and then the second NIC that is just there as a NIC specifically for the virtual machines. So if you right-click that, go to Properties, and you'll want to unbind everything that you possibly can on the NICs that you only want to use for virtual machines. So in this case, I have the VMware Bridge protocol from VMware Workstation and the VirtualBox bridge driver from VirtualBox. So since I have both, I have both of these here, and they actually will interoperate just fine. But you'll want to uncheck everything else there, at least if you're plugging it, especially if you're plugging it into an untrusted network, just to make sure that it can't bind anything on the host and potentially expose you there. Now, the process is a bit different on the server class hypervisors. Just by their nature, they don't have a full-blown OS like Windows, generally speaking, where they'll bind things to every NIC by default. So it is something to keep in mind there, but depending on what your hypervisor of choice is, it may not be something that you actually have to go in and turn off. It might be something where you, in order for it to even do something like that, you'd have to go in and turn it on. Okay, so virtual networking on the server hypervisors. A little bit different, still kind of similar concepts. There's no NAT networks in any of the server class hypervisors. Not generally something that you want to mess with in those kinds of environments. But other than that, you're kind of in a similar circumstance where you can, but the bulk of your virtual networks in these types of environments will be virtual only, essentially, or bridged over to a physical port of some sort. VLANs are much more common in this case. Depending on which hypervisor you're using, they all at least support tagging at the hypervisor level, so you can create vSwitches that are specific to a particular VLAN tag. which would allow you to have upwards of 4,000 separate networks on a single NIC. And some of them will support passing VLAN tags through to the guest VM. Generally, probably better to do the VLAN tag handling at the hypervisor's level rather than at the guest VM level. But if you're in a circumstance where you need a bunch of interfaces inside of a VM, especially in the firewall cases, then your only option past a certain point is to tag those VLANs into the VM. Like VMware ESX has a NIC limit of 12, I believe, and that's roughly what all the hypervisors will limit you to, if not less than that. So if you need more than that many networks connected, then in that case you'll have to pass in the tagged VLANs, so you can differentiate them that way, since there is a NIC limit. And with this class of hypervisor, it's also an option to pass through hardware in the underlying physical system. So it's actually possible to send the NICs directly into the VM. So the hypervisor in that case is not even touching the NICs. They're passed through directly as devices into the virtual machine. And that's kind of nice for security reasons, because it makes it essentially impossible to accidentally configure something at the hypervisor level on those devices. And it could potentially be helpful for other reasons depending on your circumstances. So it's something that's possible here. It's not all that widely done, but it is something that works well. So virtual networking in VMware ESX. So the base of that is vSwitches. And then vSwitches can have 0, 1, or more associated physical NICs. NIC bonding is something that you get with this class of hypervisor. You just don't find in the desktop stuff. And then within the vSwitches, you have port groups. Each port group can optionally have a VLAN ID, and or you can set it to pass all the tagged VLANs across. And I'll pull up a machine here to show you. And this is the web client, but the C# Windows client is more or less the same process. So if you pick your ESX host, you can go to Manage and then Networking. And we have one vSwitch 0. And you can see down here which virtual machines are associated with it. And also that it has a management network assigned. So this is common to a number of products along these same lines where you add your management IPs separately and you tie those also to a particular vSwitch. You'll want to make sure that you only tie those to an internal network of some sort. And then the physical adapters that it is associated with. So this vSwitch is a bridge to this physical NIC that is on this system. And then just like with physical switches, you can add VLANs on the vSwitch. So if you choose a virtual machine port group, here you can tell it's using an existing vSwitch, or you can create a new one. In this case, we only have one physical NIC bound to it, so we can just add a port group that has a VLAN ID on it. Let's call it VLAN2, give it VLAN ID 2. And then you'll also see whenever you click down there, the option 0 is it has no VLAN tag, and then all the VLANs is 4095. Okay, and then we have that VLAN2 network here, still within the same vSwitch, but it is a separate network since it does have a VLAN ID. So if we want to create a new vSwitch that's actually completely separate from that, similar process. So then you can choose physical NICs to go along with it if you want to. That's optional. If you have a full-blown environment with high availability and you have a setup where VMs can run any number of physical hosts, then you'll always have to have something tied to some physical NIC tied to all of your vSwitches. But if it's just a single host scenario, then you can leave it completely isolated from any physical network. And we don't have any free NICs, so there's nothing listed here. And that's fine. That's what we want in this case. And let's call it virtual only, not connected to anything outside of this ESX host. Okay, and see we have vSwitch 0, which is the original one that was there. We have the original VM network and the VLAN 2. And we have vSwitch 1. That's no physical adapters and no virtual machines on it at the moment. So now if we go into the settings of one of these VMs that we have here. This is on the default VM network right now. We can change it over to the virtual only. And then we'll edit the pfSense VM here as well. So we have 4 NICs in this one. These are in order from 1 to 4 as EM0, EM1, EM2, EM3, which makes them easy to assign whenever you do the installation. We'll leave the WAN just on VM network, and we can move the LAN to virtual only. The remainder of those aren't actually doing anything. We can disconnect those. And then if we get the console open on the firewall, we can see what addresses it has assigned to it. So it's assuming that the web interface is going to cooperate and actually pull up the console. Grab the Windows client over here while that's working or not working. And we can come back to that one in a bit. Virtual networking and Hyper-V, pretty similar in some ways at least. There's 3 different types of virtual networking in Hyper-V: external, internal, and private. Where external is just a network that's bridged to a physical NIC on the system. Internal is bridged to a virtual NIC on the host, so that's essentially a host-only network. And private is VM only. There's just no connection to direct connection to any NIC, virtual or physical, on the host. getting logged into the Hyper-V server here. Hyper-V is something that's a recent addition to supported FreeBSD. Microsoft was working with Citrix and NetApp and some other folks getting FreeBSD added as a supporting operating system. They only started that effort a couple of years ago or so, and FreeBSD 10 was the first release version that has included that support. So our 2.2 release, currently in alpha beta over at snapshots.pfSense.org, is the first release we have that would work really. At least it seems to work very well. At least the early reports are that it does well. Earlier versions, they will sort of kind of work with the legacy network adapters. You may have to hack them a bit to manually ifconfig down and up the interfaces. It's not something that I would recommend bothering with until 2.2. And that's what I'm actually running on this machine here. So you can see the connection type for the virtual switches that are here. It has the external network, internal, and private. And then the internal only. If we step back a bit here. Whenever you're in the Hyper-V manager, you have the virtual switch manager over here, and that's where you can create new ones here, and then you can modify the ones that you already have set up. And then you see here the internal vSwitch that's Hyper-V's virtual adapter that it added. And we have two physical NICs, one that we're just using for LAN purposes and one for VM. And then on the VM NIC, we have everything except for Hyper-V disabled. Thing's taking its time. Let me go back. So now you have some grasp of how the virtual networking works in this case. Just talk about virtualizing production firewalls in general. It can be a great fit in many circumstances, but not necessarily always. There's certain scenarios where it can be a really bad idea. One in particular that actually bit us internally a couple of times, and we've seen it bite customers before, is if you need your firewall to route to the virtualization servers, their management servers, or anything else. So if your VMs are all dead and you cannot get to those machines to resuscitate them without having the VM firewall, you're going to have a bad time if all your VMs stop and you can't get them started without actually going and logging back in. And that doesn't happen a whole lot, but it's enough of a risk that if you absolutely must have your firewall to route across to the networks where you manage your virtualization environment, make sure you have at least one physical firewall. In that case, if you're running high availability, then maybe your primary is physical, and then maybe you have a secondary that's virtual, since it's probably pretty unlikely that you would lose the hardware on the primary and lose your virtualization environment at more or less the same time, unless something really catastrophic happened that would knock out two physical firewalls anyway. But that's one to really be careful of, especially if it's in a remote colocation facility or something like that. We've seen people get into some multi-hour outages from that, where all their VMs just died and they couldn't start any of them back up until they got somebody on site to plug in and access them locally. Here's your typical basic architecture. So the hypervisor host has at least two NICs in it. For just a basic example, I've got two here. One of them goes to the LAN, the physical LAN usually, and then the other one goes to your internet connection, or a switch that goes to your internet connection. Maybe direct into a cable modem or a DSL modem or something along those lines, whatever CPE that you have there from your ISP. And then you have two bridge virtual switches. You got one that's bridged to the WAN NIC and one bridged to the LAN NIC. And then you got your pfSense VM that has one NIC on LAN and one on WAN. So it's functionally equivalent to having a physical machine out here that's directly plugged into the ISP and the physical LAN switch. There are some performance considerations. There is overhead versus just running it on the bare metal, but the vast majority of the time, probably that really doesn't matter. It's many times actually faster because the machine that you're running your ESX or whatever your hypervisor is significantly faster than whatever machine that you would have bought just to run the firewall. So in that case, you can actually end up with better performance than you would have with whatever firewall hardware you were going to use before. Now, granted, there are some potentially big caveats there if you want to use high availability or any kind of bridging or anything along those lines that we'll get into. So for high availability or bridging as well, if you're doing any kind of bridged VPNs or bridging between virtual networks or things like that, promiscuous mode is often required if you're using the stock virtual switches in most hypervisors. So unlike a physical switch that has a cam table and it can see that you can have however many learned MAC addresses that you're allowing it in your switch to have, VMware and a lot of the other ones, I'll just use VMware as a reference since they're the most widely used of the bunch. VMware's stock vSwitches have two options. You get only the traffic destined to the MAC address of the virtual machine on that interface, or you get traffic destined to all the MAC addresses. There's no in between. So if you're using something like CARP, where you have to have the virtual MAC address for the CARP IP to function, or the same for VRRP or HSRP if you're using some other kind of routing redundancy protocol, then you have to enable promiscuous mode on the port group of the firewall at least. That's less than ideal, but it's the only option with VMware stock vSwitches as of now. The problem with that comes in whenever you have a lot of internal traffic. So like in the image at the bottom here, where you have server 1, server 2, and the pfSense all on the same virtual network there. Normally, pfSense would only see the internet traffic, and that's generally not all that much, at least relative to what many times you're bouncing around between servers inside your network. And normally in a switch network, you would not see, say you have a 1 gig transfer going between server 1 and server 2. pfSense would never see that in a normal switch network. Where you have to flip on promiscuous mode on your virtual switches, then that whole gigabit per second gets dumped to the firewall's port, as well as the internet traffic. So what ends up happening is if you have a lot of traffic on your vSwitches and you're in a scenario where you have to enable promiscuous mode, you fill up the firewall's NIC with garbage traffic that it cares nothing about. But you have no means of telling VMware's vSwitch not to send uninteresting traffic, because it's either the VM's MAC address only or everything. So that's a. There's still a lot of people who run HA in within VMware or other products that have this exact same kind of restriction here, including with the default vSwitches. It just depends on how much traffic you have on your internal network. It it can be practical, and there's just some circumstances where it's just impossible. You basically either have to replace the vSwitches with some of the third-party ones that are available out there that will let you just send 2 or however many max that you need and not dump all the traffic to the firewall, or go with physical firewalls. In most of the cases I've seen, people have gone with physical firewalls. Let's see if that finished. And now I cannot type in it for some reason. See if I get that change made to the other, or on the other machine here, and then I can show the rest of it from there. I can show the same thing in VirtualBox here. Okay. Now that machine should be reachable. Just to make sure, I am going to go to the developer shell, and there's a playback command here to enable allow all WAN. Whenever you're working in a virtual machine that's just for testing or development purposes or something like that, you can just run that to open up the WAN firewall rules completely and turn off block private networks as well. Not something you want to do on a production internet-facing machine, but it's quick and handy if you're in a VM test circumstance like this. Okay, and we have a pretty typical setup here with the WAN and 2 LANs and a second WAN as well. The LAN 1 is where the other machine is, and we do have DHCP enabled there. So if we go back, it's got me stuck in there because it wants me to hit right control to release, and Macs do not have a right control key. Okay, change that so I don't get stuck there. I've got this machine behind that one as just a test client. And we can see we got a 10.5.1 address that is in our LAN subnet. We should be able to get out to the internet. Yeah. Okay, just go back to review the, we got the test firewall here. It's got, one of its NICs is bridged to the NIC that is on the Windows machine here that's actually running VirtualBox. The other NIC is on that test LAN that I created that's specific for this, so that's bridged to the second physical NIC in this system. And then the second adapter is internal network test FW1-LAN. And then this Ubuntu machine has the same test FW1-LAN -lan specified there. So this is essentially the environment that we're looking at here. Where we got the LAN NIC to just a strictly internal virtual switch, test host behind that, and then just a bridge interface out. In this kind of scenario, you could just as easily use NAT and probably lower your risk of breaking things in the process. This type of setup is a good way to test out changes if you're not entirely sure how your production environment is going to react to them. So maybe you want to make some changes to your firewall rules and test it out on setup like this before you actually put it into production, or maybe you're running Squid and SquidGuard and you want some place to test out your settings before you push them to production. Really, any area of the system, this type of a setup is a good means of testing it. For some things, you can get by with something as simple as this, where you just have a single test host behind the firewall. If you have a more complex network, or if what you're looking to work with is a lot more involved than just some basic maybe proxy or firewall rule or NAT kinds of things, then you can replicate however big of a network that you want. And if you have like a web hosting environment where you might have a few database servers, several web servers, maybe any number of other things, mail servers and things like that, you could replicate a portion of those or even all of those and do a test setup where you can, if you're going to make any kind of major changes, you can make sure those check out first in the test setup before you put them into production, and you can test upgrades before you push those into production as well. A lot of possibilities with setups like this, even if you're not doing any kind of development work whatsoever. It's nice to have just to try out things and verify that they're going to do what you think they're going to do when you actually put them into production. High availability considerations. A lot of people wonder if the high availability that's offered by at the hypervisor level, where you have shared storage and multiple hosts, and you can migrate machines across them, and is that a good replacement for the high availability at the firewall level? Uh, it is it's not a replacement, because there's a lot of things that you can do whenever you have high availability at the application inside of the VM that you just can't do otherwise. Like if you need to upgrade a system, or potentially any number of other causes, you're not necessarily going to get any kind of redundancy at all with the HA at the hypervisor level. So it's not a replacement for the HA that we have within pfSense. You can use it in combination with that if you want. It's just usually not much reason to do so, if any. The people who run HA pfSense in virtual environments, they have one VM that's tied to one physical piece of hardware, and another VM that's tied to another particular physical piece of hardware. Sometimes they do let them migrate from one to another, but have it set up as such to make sure that they never get migrated both to the same host. So that way you have much better and faster failover time than what you could ever achieve with the HA at the hypervisor level. So it's not bad to use them in combination, but don't skip on the HA inside the VM, whether it's pfSense or anything else for that matter, because keeping the VM running is only part of making sure it's actually doing its job, passing and blocking traffic in this case. just a bit on some interesting hacks that you can do with virtualization. This particular one on the screen here is about the sixth thing I tried to get internet going for all the devices that I had when I was traveling one time. I had a LTE card as my only means of getting internet access. Had a pfSense, small pfSense box with me. I travel with a small Zixel router. It's battery powered, so it's kind of convenient to have. And a couple of laptops, generally a couple phones, iPad, all that good stuff. In this case, this card, this Verizon LTE card, there's an oddity with it that if you do not have 4G or LTE signal, you cannot connect from Linux, you cannot connect from FreeBSD. So I failed with the trying to connect to it on pfSense. I failed trying to connect to it on the Zixel router that I have, and there's apparently some crazy workaround that's possible if you want to get into changing parameters on the actual card. It just wasn't worth the hassle. So put it into my MacBook Pro, tried to use its internet connection sharing. Well, that didn't work. It wouldn't NAT across uh, the 3G connection properly. So, okay, really need internet access for all the hosts on the network. What the heck am I going to do here? So, I had the wireless AP that's built into the Zixel router. Left that as the wireless access point. Ran its Ethernet port over to the MacBook Pro's Ethernet port. Set up a pfSense VM. Set up its LAN to be bridged to the Ethernet. So all the wireless devices were coming into its LAN, and it was serving DHCP out to those. And then the WAN of it was connected to the NAT vSwitch. And the NAT vSwitch did work. It was just the built-in OS 10 internet connection sharing that wouldn't work with that card. So that was a way for it to get out to the internet. So this pfSense VM inside of the laptop, bridged to the Ethernet adapter out to the wireless access point, natted once there, uh, natted once here by pfSense, natted once here by Parallels or VirtualBox. I think I was running at the time. I don't remember which for sure. And then natted a third time once it got out on Verizon's network. So triple NAT is quite ugly, but it worked, and that was the important thing. And that's the type of thing that you would never, ever, ever set up in any kind of permanent scenario. But if you're in a pinch and you got to have something working, and it's just a temporary thing anyway, because you're not going to be there all that long, that kind of a thing you can toss together with VMs and do some ugly but kind of neat and definitely works really well type of things. All right, any questions? Carl had mentioned the ease of VLAN hopping would preclude putting WAN and LAN on the same interface. Uh, it's generally not that easy. It can be possible, but yeah, I mean, because it can be possible, and it's sometimes can be hard for you to tell how practical it is to do that. My recommendation in general is if you have networks that have significantly different trust levels, don't mix them on the same physical equipment. That that line kind of gets blurred whenever you bring virtualization into the mix. There is that possibility for human error that gets introduced there. But I really wouldn't hesitate to at least plug your internet connectivity into different physical NICs on your uh, host hypervisor servers. And the other part of that question was about the risk associated with the uh, robustness as related to security. I think that question was from before I went through that exact topic, but just still any other questions beyond what I discussed there. Glad to take them. What's the virtual subnet address range? I'm not sure what screen we were on at that time. Uh, KVM is one of the questions about KVM. That is a supported option. Uh, a good deal of people use that. It works very well. It's something I would not hesitate to use in production. Same for Zen as well. VMware is definitely the most widely used of the bunch. Uh, just as it is in general, and they've supported FreeBSD from day one. So they have a solid support for it and have for many years, and they tend to kind of be ahead of the others in FreeBSD support. But the others are very much solid and getting much better in FreeBSD 10. A lot of things have improved with Hyper-V in particular, and a number of other things in like the VirtIO drivers and things like that have gotten better as well. So uh, the 2.2 release will be even better in VMs. Yeah, Proxmox is what I actually use KVM with, but not OpenVZ. Uh, we do test with KVM VMs on Proxmox. So that question was about the test network inside the 10. Which still don't remember where I would have seen a virtual subnet address range. If you remember any more specifically, Carl, whenever where you saw that. Answering Brian's question in the meantime, a target date for 2.2 release, and nothing set in stone, but before the end of the year. Is what we're how much before the end of the year that I won't comment on that. We really wanted to have it out by now already, but there's always more work than you think there is. Oh, so the setup that we were looking at before, which should be this one, which I think is over here. So I'm guessing this is maybe the range that you were referring to, Carl, and this is just the DHCP range. So this is configured to hand out .100 through .199 on that LAN one network, which is the internal virtual only network that's in VirtualBox on that Windows machine. So this is a /24. So the question was, what was the outer? So at the moment, this is just sitting on a private external WAN side address that's just on a different part of our internal network where we have build servers and stuff. It's miscellaneous things that I jumped one of my NICs of the test VMs onto that network. A lot of times what I'll do when I'm doing these hangouts or any other kind of demo, you'll see that the fourth NIC that I have here has what looks like a public IP on it. That's actually the RFC for documentation reserved subnets. There's 3 of those, and then I have an internet router VM that has those on it, and then it acts essentially like a multi-WAN router, and it also does NAT from there. But it at least looks appears to have public IPs in that case. So all the networks that are on this are /24. Any other questions? So Carl asked, was the virtual pfSense network a subnet of the physical one? No. So in this case, they are essentially the same as if there was if you took this VM here out, this is the one that has that test client behind it. If you put this on a physical machine that had 4 NICs, and each of those NICs was plugged into a completely separate physical switch, that's the same scenario that we have here. Each of these interfaces has its own unique subnet on it, and they're all separate and isolated from each other. And then the only part that's actually on a physical network in this case is the WAN, so that's bridged out to one of our dev networks. The rest of it lives strictly inside of the VirtualBox in this case. And then from here, this is where I usually have the fake public IPs, or at times I have real public IPs on that are just available for testing purposes. And so then this goes up to another set of firewalls from there where it gets natted out to the internet. Any other questions? Is there a performance difference between Hyper-V and VMware? That I cannot answer because we just really haven't done enough in-depth testing on Hyper-V to be able to tell you. Any kind of difference, any major difference there, I'm thinking would be something specific to FreeBSD, more so than anything architectural about one or the other. I'm sure there's, depending on the workload, one is probably a little faster here, and the other one might be a little faster in some other workload, depending on the OS as well. So I think any significant difference that we'll find between Hyper-V and VMware will be specific to FreeBSD and not so much the hypervisor. Beehive. Actually, I had made a note to talk about that. I'm glad you mentioned that, Carl. So yeah, there is a BSD hypervisor called Beehive that is in our 2.2 release, actually. And that is something that we will probably be seeing more of later down the line. But that's yeah, everything we talk about today was in the context of running pfSense as a guest, rather than as running the hypervisor on pfSense itself. So Beehive does give us that ability to run VMs on the firewall. So uh, as a lot of the newer hardware is coming out, you have so much more hardware resources available, even in kind of like the mid-range appliance platforms that you'll never use at all as a firewall, especially in a smaller environment. So people really would like to run FreeNAS or something as a virtual machine, and then you could also pass the disk directly through to it, so it could handle that kind of thing. It, as well as maybe looking at getting rid of at least some packages in the way that they stand right now and turning them into virtual machines. So you have some better isolation there for security reasons and uh, maybe performance reasons if you want to limit how much memory they can use or something like that, so they don't run away with the system. Or there's a lot of exciting possibilities that now that Beehive is there, and yeah, you'll definitely be seeing more about that from us in the next few months. Yes, yeah. The question was pfSense could be a guest of a Beehive system. Yes, that's already being done. I'm not sure how widely, and it's not something it has thousands of production installs out there, like probably any other hypervisor you could possibly name, just because it's relatively new. But yeah, there are instructions out there for running pfSense on Beehive. Yeah, though the running of multiple instances on one physical machine of pfSense itself, probably not. I'm trying to think of what the practical use case for that would be. I guess it depends on what you're running on those instances. Maybe if you're maybe you want to split out like your Squid and SquidGuard to a separate proxy server VM. That would be interesting. Um, or yeah, internet router and a firewall. I mean, I guess you could yeah, you could split those two roles out if you were in a position where that was necessary. Yeah. The ability to discrete networks would be kind of yeah. I get what you're saying there, Carl. Just knowing what things that we have talked about before, that I just won't start blurting out information about the kind of stuff that you guys work on without your permission. But yeah, I mean, I could see some cases where maybe you would build a multiple firewalls on the same physical piece of hardware, keeping in mind that okay, I may need to split this portion off of it at some point, or yeah, something along those lines. Uh, could you do some with jails? Was another question. To some extent, you can. Jails are a really good solution for certain things, uh, but they're more for like server purposes rather than to run something on top of a firewall. So there are some things that you get with a hypervisor you just don't get with jails, like specific resource limits and the ability to run completely different operating systems. You can run Linux and Beehive, and Windows is apparently coming soon. So yeah, jails in theory are capable of some of those things, but Beehive really goes so much further than that and gives you so much more flexibility and more options. Okay, one last chance for questions. Running different packages from pfSense into jail, rather than just on the system itself. That that is a practical option of sorts. IPIMI features on server NICs is an issue. An issue in what context? And generally speaking, no, it's um, not a problem. That's something that's widely used. Usually on servers, they have a dedicated NIC port where the it's not actually sharing a port. And if you do have one of the kind of other lower end systems that have the shared NIC, so they don't have a dedicated IPMI port, that I don't know if it would cause issues necessarily, but you would want to be careful if you are using it how you set it up, so you're not, some of those like come DHCP enabled by default, and you plug them in, they're pulling a lease from wherever they can get one. So that's something to keep in mind if you do have any hardware along those lines. And then if it is actually something that you use, if you do have to use a shared NIC, you probably would want to VLAN tag the IPMI, so its traffic is separate from anything else, whether you're virtualizing or not. It's a good idea. But I don't think it would actually, in either case, it wouldn't actually interfere with the proper operation of the system, other than the fact that, if it gets open on the internet, it'll be one of like 300,000 devices that are open with a default password, IPMI devices. There was another research paper that came out, I don't know, 2-3 weeks ago or so, where they scanned the entire internet and found upwards of 300,000 IPMI devices open to the internet with known security issues like the default admin password, which is that's like even worse than having the OS exposed in some way, since you have essentially full control of the hardware at that point. All right, any other questions? Oh yeah, look forward to meeting Daniel. It says he's going to be at the training in September. Hopefully, some of the rest of you will be able to make it as well.